Now dear student, we are going to discuss question number 3.19, and in this question it is given to you, suggest a suitable physical situation for each of the following graphs. Clear? So first we are going to concentrate on graph number A. Now concentrate. So now we have to actually find that this graph number A is representing which situation. Clear? So let's suppose if I am saying, let's suppose here we have a wall. Let's suppose this is a wall, and let's suppose here we also have one wall. This is wall. Clear? And we have here also wall. Clear? Yes. Now let's suppose at any position we have here, let's suppose this is a football. This is football. Now let us try to understand. Let's suppose this is initial position of a football. Let's suppose I am saying this is x equal to 0. I am taking this direction is positive x axis. Clear? So now you can say, if I write here, let's suppose this is P, and let's suppose we can say this is T. Clear? Or let's suppose if I am saying this graph is representing what? This graph is representing the position of this football is not changing with time. Position of a football is not changing with time. It means we can say here this football is at rest. Clear to everyone? Now let's suppose a person kick this football in a right direction. Clear? So definitely we know now its speed will increase. Yes or no? So we can say this slope represent here, actually we can say this is xt graph, and the slope of xt graph represent this is velocity, or we can say magnitude, this is speed. Yes or no? So we can say here we are having a positive slope. Positive slope means what? We are having positive velocity. Clear? Because we can say this football is initially moving in this direction, so its speed increases first. After some time, what will happen? After some time, when this football hit this wall, again it will move in an opposite direction. Yes or no? But now it will move in with a reduced speed. Clear? And it move reduced speed, and finally again it come to the same position. Clear? Because here we are also getting x equal to 0. But what will happen? After that, after reaching this position, this football is now moving in a left direction. Clear? That's why we can say here we are getting negative displacement. Yes or no? And when it strike to this wall, when this football strike to this wall, at that time we can say it stick to this wall. Clear? Or we can say it comes to a rest. Yes. So now we can say this is the situation that is shown to you in a graph number A. Clear to everyone? Yes or no? Yes. Now listen. Now if we talk about situation number B, so this situation number B represent what? Let's suppose if we talk about motion under gravity. So let's suppose we have a ball. We are throwing a ball in a vertical upward direction. We know if we are providing some initial velocity, after some time we can say with the time speed, or we can say velocity of that ball decreases. Clear? At the maximum height we find velocity 0. Clear? So now you can see from this graph, if we talk from this point, so you can see here speed velocity that is decreasing with the time. Clear? It means we are throwing a ball in a vertical upward direction, and if you write here equation of motion, you can write like this: v equal to u plus at. Clear? We can write in a terms of time like this: v minus gt, because we are throwing a ball in a vertical upward direction and acceleration due to gravity act in a downward direction. Clear to you? So we can say here we are getting negative slope. Clear? So you can say this is negative slope. But what will happen when this ball, after that what will happen? At one point where we can say when ball reaches to the maximum height, its speed becomes 0. So this is that position, and after that this is again coming in a downward direction. Now it means we can say its speed is increases, but direction of a velocity is different. Clear? When this ball strike to the ground, after striking to the ground, some energy of that ball is lost, and now it will move in an upward direction with some reduced speed. Clear? And we can say now again direction of that ball changes. Yes or no? And again we can say again velocity decreases up to the maximum height. Again ball is going in a downward direction, again collide with the ground, and again move in an upward direction with reduced speed. So we can say like this, after some time its energy is completely lost and finally it will come to rest. Clear to everyone? So this is a situation that is related to graph number B. Clear to everyone? Yes. Now, if we concentrate on graph C, this graph is actually given to you between acceleration and the time, and whenever there is some change in an acceleration, it means we will find jerk. Clear? So what is this situation? Actually we can assume, let's suppose I have a cricket bowler, I am throwing a ball in this direction. Clear? Ball is going, let's suppose, with some uniform acceleration, but when it comes to the batsman, a batsman hit that ball and there is a sudden change in an acceleration we find. So whenever there is a sudden change in an acceleration within a short interval of time, we can see that is jerk. Yes. So after hitting by the batsman, what will happen? We can see again after some time ball will move with some constant acceleration, or we can say here the acceleration is 0. It means ball is moving with uniform speed. Clear? Here initially ball is moving in a uniform speed. Clear? Again I am explaining to you. Let's suppose if I am throwing a ball with uniform speed, when batsman hits that ball, at the time its acceleration sudden increases, and after hitting ball again come to uniform motion. So this graph is representing this situation. Clear to everyone? So I think you got all the clarity that which situation these three graphs is representing to you. Clear to everyone?